Okay, so in this video we are going to solve a 2002 AP Calculus FRQ question, Form B. It looks like it's on related rates. So it says ship A is traveling due west towards the lighthouse at a speed of 15 kilometers. So he's traveling this way. So that means dx dt is going to be negative because it's actually decreasing 15 km per hour. And it says ship B is traveling due north at a speed of 10 kilometers per hour. So dy dt is positive because he's traveling away. So that distance is growing. Okay, let x be the distance between the ships at ship A and Lighthouse Rock at time t, and y be distance. So now it says find the distance in kilometers between ship A and ship B when x equals 4 kilometers and this is 3 kilometers. So now it says find the distance. Well, it's got to be 5 kilometers. It's a 3, 4, 5 triangle, but let's say you didn't know that. So you would use Pythagorean theorem. X squared plus y squared equals c squared. So now when you do this, you're going to plug into 4, so you're going to get 4 squared plus 3 squared equals c squared. 9 plus 16 equals c squared. 25 equals c, so 5 kilometers. Usually you need units. That's how big c is. So now we have c equals 5 kilometers. And we don't know dc dt, which is probably next question. Find the rate of change in kilometers per hour of the distance between the ships when x equals 4 and y equals 3. It is the next question. Go figure. So now you have x squared plus y squared equals c squared. If you have a constant, you plug it in. Like if you have a ladder height, that never, not the height, the ladder, how big it is, that never changes. But in this case, everything changes. So now you just differentiate. Derivative of x squared is 2x dx dt, since it's related rates. You're talking about the differential for time, plus the derivative of y squared is 2y dy dt equals 2c dc dt. Now you could divide everything by 2 and get rid of 2. So I'm just going to cross them out now. Make my life easier. So now x is 4. dx dt is negative 15 kilometers per hour plus y is 3. dy dt is 10. C was 5. And we're trying to find dc dt. So now we're going to get negative 60 plus 30 equals 5 dc dt. So now you're going to get negative 30 equals 5 dc dt. So dc dt is negative 6 kilometers per hour. Usually you have to write a sentence after this. So your sentence should be when the ships are 3 kilometers and 4 kilometers apart, and you should probably say which ship is which. The distance at that time would be dc dt would be the distance is getting smaller by 6 kilometers per hour. That's what the negative 6 kilometers per hour is. Okay, give me 1 second while I pause this video and I clear the canvas so we could do part C. So the next part of the question says, let theta be the angle shown in the figure. Find the rate of change of theta in radians per hour when x equals 4 and y equals 3. So it says find the rate of theta. Okay, so it wants you to find y over x, y over x, y over x. If you have y over x, that's opposite over adjacent, so it's got to be tangent, right? So we're going to use the tangent function. So tan theta equals y over x. Okay? Now, when we start solving this, we're going to have to differentiate. So derivative of tangent is secant squared theta, but you need to take derivative of theta, which would be d theta dt, which is actually what the question is asking, what the change of the angle is, equals, this is a quotient rule, so derivative of top, which is going to be 1 times, well, dy over dx, or dt in this case, times the bottom, minus derivative of the bottom, derivative of x is dx dt, times the top over bottom squared. So derivative of top times the bottom minus derivative of bottom times the top over bottom squared. So now we need to find secant squared. Secant is really 1 over cosine. So cosine is really adjacent over hypotenuse. So secant squared would be hypotenuse over adjacent. The hypotenuse is 5 because it's still a 3, 4, 5 triangle. 5 over 4, right? Because that's the adjacent. Yeah, that's the adjacent right there. So the 5 is here. So now we're going to have 5 over 4, quantity squared, d theta dt, equals dy over dt is the 10, x is 4, minus dx dt, that's the negative 15, put it in parentheses, y is the 3, all over bottom squared, which is 4 squared. So now when you start solving this, you're going to get 25 over 16 d theta dt equals 40, negative 45, so plus 45. Yeah, plus 45 over 16. So now you're going to get d theta dt equals 85 over 16. I'm going to multiply by 16 over 25. I'm getting rid of this. So now the 16s are going to cross out. And now I have 85 over 25. You could divide those by 5. And now you're going to get 17 over 5. Now we have to think about the units that we're using. Since we're talking about theta, and it said find this in radians per hour. So we're going to say radians per hour. So usually you have to write a sentence, and you would say, when ship A is 4 kilometers away and ship B is 3 kilometers away, the angle is actually getting bigger by 17 over 5 radians per hour. I hope this video helped.